Hey guys, we're going to do a little math review for physics since it's probably the beginning of the school year and you've forgotten some of the basic math that you need for doing physics. One area that people frequently have trouble with initially is doing unit conversions for things like rates, higher order units, and density units. So what I mean by a rate would be something like, meters per second or miles per hour or whatever. Higher order units are going to be things like cubic meters, for example. And then we have things like density units. Really, these aren't actually that much different from rates or ratios. So things like grams per milliliter is maybe what you're used to from chemistry, or grams per cubic centimeter. Typically, physics is going to use something like kilograms per cubic meter. So again, you can see it's got some higher order units in it in addition to being a ratio, and we will actually deal with that one in this video. So to begin with, let's deal with a rate. Let's suppose that this is a bullet and it's going at 700 feet per second, and we want to know what that is in miles per hour. Always begin by writing that unit as some kind of a fraction. So if it weren't like feet per second, if it were, say, just like feet or feet squared, I'd put it over 1 so that there is something in the denominator. And what I'm going to do with it is multiply it by a series of fractions whose value is 1. Okay, now, what in the world do I mean by that? Well, these are called unit multipliers, okay? And so an example of a unit multiplier, an irrelevant one in this case, would be something like 100 centimeters per 1 meter. Okay, so that's a unit multiplier, and the reason we say it has a value of 1 is the thing on top and the thing on the bottom have the same value. So let's say that I'm first going to begin by trying to convert the time. Well, if I'm trying to go from seconds to hours, I need to know how many seconds are in an hour, or else I need to convert from, say, seconds to minutes, and then minutes to hours. In this case, I'm just going to go straight from seconds to hours because I can do 60 times 60, and I know that that is 3,600 seconds per hour. Now, before I plug everything in, I think it's really important that you understand how to orient these unit multipliers. And the way that you orient it is always so that you cancel out the unit that you no longer desire and leave in the unit that you are looking for. Now, in this case, the unit that I said I was trying to cancel is seconds. Seconds is on the bottom in my 700 feet per second. Therefore, in order to cancel it out, my unit multiplier of 3,600 seconds per hour will have to have the seconds in the numerator. This statement, 3,600 seconds per hour, is true whether I write it like this or like this. It's saying the same thing, right? However, in this particular case, I want to use the orientation of it where seconds is on the top because something in the numerator will cancel something in the denominator. In this case, the something I'm trying to cancel is the units. So I must orient it with the seconds on the top. And now I will go ahead and put in my numbers, 3,600 seconds per 1 hour. Okay, so you got to get the units set up in such a way that they're going to cancel. And then in terms of figuring out where the number goes, it's always larger number with the smaller unit, right? If I said 3,600 hours per 1 second, that would be remarkably incorrect. That being said, though, people will very frequently write bogus things like they'll say, let's see, 1 meter in 1,000 kilometers, because they know kilo means oh my goodness, no. 1 meter. Right now, hold up your hands. Show me a meter. I mean, you can probably do it. Hold up your arms and no, you can't show me 1,000 kilometers with your arms. It's not possible. Okay, so for those two particular things right there, 1,000 meters would be 1 kilometer. So it's always going to be the larger number with the smaller unit. Meters are smaller, therefore you need to have the 1,000 with the meters because they are small. Okay, let's look at the next fraction here. We've got to convert now feet to miles. Now, I'd like you to take a moment and pause the video and think about where you're going to put it. If you don't remember how many feet are in a mile, the number is 5,280. That is not a thing that you're going to really have to know for physics, because we're honestly never going to use feet and miles very much at all, if ever. You do need to know your metric prefixes, all right, but whatever, it's 5,280 feet in a mile. Pause me, take a moment, figure out, where is the 5,280 going to go, and where are the feet and the miles going to go in this fraction right here. Okay, so feet will go on the bottom. Well, but Mr. Errico, when you did the seconds, you put the seconds on the top. Well, that's because when I did the seconds, I was trying to cancel out seconds that were on the bottom. So bottom things are canceled by top things. Well, feet is on the top, okay? It's in the numerator. Therefore, when I write my unit multiplier, I will need the feet to be on the bottom in order to cancel out the 700 feet from the numerator. All right, now let's get that 5,280 in there. There it is, bigger number with a smaller unit, for an answer of 477 miles per hour. If you're at all confused on how we got that, remember when you type stuff into your calculator, anything on the top is going to get multiplied. And then anything on the bottom is going to get a division symbol in front of it. So you could write it out like this, and that should give you 477 miles per hour. Next up is higher order units. So I picked cubic units, but for that matter, square units are considered higher order units as well. I'd say the most common problem that people have with higher order units is they look at something like this and they're like, oh, yards and feet. Oh, I know how many feet are in a yard. So the answer is clearly 0.3. Makes sense, right? Because I multiply, but no, you do not multiply by 3. That's not actually how this works. To understand why you can't just multiply by 3, let's actually draw out what a cubic yard is. So a cubic yard would literally be a box that was 1 yard in each dimension, length, width, and height. Now, everyone from America knows that 1 yard is 3 feet. Okay, so there we are. I could convert each of those dimensions into feet, and now I would have 3 feet by 3 feet by 3 feet. So that means 1 cubic yard is actually not 3 cubic feet. It's 27 cubic feet. 3 times 3 times 3. All right, now that's not really how I want you to approach doing these, is drawing a box and multiplying it out and that sort of thing. You can do it without knowing the number of cubic whatevers there are in the cubic other thing. Instead, there's a way to do it using the factor label method like we were doing in this problem up here. So if I want to convert 0.1 cubic yards into cubic feet, I can begin by writing out my unit multiplier here of 3 feet per 1 yard. However, if I just multiplied by 3, we already said we know that's wrong, that wouldn't cancel out the unit completely. Remember what cubed means, right? This is yard times yard times yard. That's what cubic means in general for anything, including units. So if it's cubic yards, that means I need to use this unit multiplier 3 times to cancel out all 3 yard units. If I stopped now and just multiplied by 3, what I would have is feet yards squared or something like that, which would be wonky units that no one uses. So I have to either write out that unit multiplier 3 times, or I could write it out once and then write a cube around it. Right? See that little cubic? All right. And so if I cube that multiplier, that's the same thing as using it 3 times. So final answer, after we put it all in our calculator, is 2.7 cubic feet. So now that we have a little bit of experience with cubic units in this context, let's move on and look at them in the context of density units. So suppose we're looking at a hunk of iron has a density of 7.87 grams per cubic centimeter. Now I'm going to ask you two questions about this. One is, convert those units to kilograms per cubic meter. And the other is, what would the volume of 2 kilograms of iron be? So remember, to begin with, write out the density that you're trying to convert, or the whatever you're trying to convert, as a fraction, like this. Next, we need to convert one or the other of these units. So let's begin with the cubic unit. Pause the video and see if you can remember how to set this up. This would be applying the sort of two different kinds of conversions that we did previously in the video. So try and set it up. Pause the video and then resume when you think you've got it. And this is what it could or maybe should look like. You'll notice the centimeters unit is on the top and the meters unit is on the bottom. And it's set up this way, as usual, so that the centimeters can cancel. And we had to cube it because, of course, this is not just centimeters, but cubic centimeters. So really, we need centimeter, 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 right? You have to use that conversion factor 3 times to cancel out all 3 of those centimeters units. And it's not going to say 1 centimeter over 100 meters because that would be false. Remember, it's the bigger number with the smaller unit. Centimeters are smaller. All right, now try and set up grams to kilograms. And there it is. Grams on the bottom, so that it cancels the grams on the top. And it's 1,000 grams per 1 kilogram. Grams are small, kilograms are big. The bigger number goes with the smaller unit. Remember, you do need to know your metric prefixes. So, for example, I expect you to know that centi is 100 because you know there's 100 years in a century. Kilo, you just have to remember, but it's 1,000. Most of the important metric conversions are like 1,000, a million, a billion. Okay, and so the answer is, after you get all done multiplying and everything, 7,870 kilograms per cubic meter. All right, now what about the volume of 2 kilograms of iron? For this, you need to remember your density formula from, seems like ages past. Density is mass divided by volume. Okay, so we can plug in our density, all right, and we can plug in our mass, and we'll get this. Now, the next step, of course, is solve for the volume. Now, I did this specific example where I wanted you to solve for the volume because a lot of people mess up the algebra here. So if you work it out and you get an answer that's something like 3,900 whatever, you've done it wrong. You have messed up your algebra. 2 kilograms of iron, yeah, it's pretty heavy. It's like 5 pounds. But if you're going to tell me that that's something like almost 4,000 cubic meters of iron, think about what a cubic meter looks like. You can't even lift a cubic meter of iron. That's just an unreasonable amount of mass. So maybe we're messing up the algebra if we get 3,935. All right, so let's approach the algebra a little more carefully. The first step is to get the v off of the bottom. You're trying to solve for v. So the first step is not divide by 2. The first step is multiply both sides by v. That will cancel out the v from the right side. And now we'll divide both sides by the 7,870. And we get the correct answer of really relatively small number, but of course, cubic meters are enormous, and 2 kilograms of iron is nowhere near a cubic meter. All right, well, I hope that was helpful. Please, again, show work like this anytime you have to convert units on homework from my class, and everything should go very smoothly. Thanks, guys.